Hi class, welcome back from spring break. I know it probably wasn't what you had hoped for, but hopefully you got some time away from schoolwork and enjoyed spending some time with family. Today we're going to move on in Unit 7. Remember we talked a lot about exponential equations in the first couple weeks of e-learning, and today I'm going to move on and introduce something called logarithms. So, in order to understand a logarithm, we're going to start by reviewing what we know about exponents. And I want you to specifically consider this equation here. 3 to the x equals 81. Now, if I gave you a couple minutes kind of as a warm-up in class and I asked you guys to solve for x, I assume many of you can come up with the answer. Okay, so maybe pause the video, see if you can come up with a solution. Okay, but what we need to think about here, we know that when we have a base and an exponent, we're trying to figure out how many times do we have to multiply 3 by itself to get 81. So we know 3 times 3 is 9, and if we multiply by 3 again, we get 27, and if we multiply that by 3, we get 81. Okay, and you might need a calculator to kind of verify that. But what we found is that 3 to the 4th equals 81. Okay, and because the exponent here is x, we can say that the solution to this equation is x equals 4. Okay, now when we write and evaluate logarithms, we're doing something very similar to the problem we just did. Okay, so 3 to the x equals 81 is equivalent to writing log base 3 of 81 equals x. So the point I'm trying to make here is that when we evaluate logs, we are looking for exponents. So I'm going to try to color code this for you. The base of the exponent 3 becomes the base of the log, okay? And that base is a little bit smaller than the rest of your terms, and it falls below your normal line that you write on. Okay, the exponent, this is what we're going to be looking for, is what the log is equal to. So logs equal exponents. That's one of the takeaways I want you to understand after today's lesson. Okay, and then lastly, we have this term here, and this is called the argument of the log. Okay, so the argument of the log is equal to the power. If 3 to the 4th equals 81, then log base 3 of 81 equals 4. And so we call this term here the argument. Okay, so this is just kind of a general introduction. I think once we do some problems, this will make a little bit more sense. So the first set of problems that we're going to talk about, okay, we're going to evaluate some basic logs. So if we want to evaluate log base 4 of 16, okay, I want you to start by putting a little box here. Log base 4 of 16 equals what? Okay, and then what we're going to do, we're going to start with the base of 4. That's going to become the base of the exponent. And we're trying to figure out 4 to what power is 16. Okay, so we know that 4 squared is 16. And so if 4 squared is 16, then log base 4 of 16 equals 2. So logs equal exponents. Okay, let's try that again. So the next one, the base of the log is 2. So the base of the exponent is 2. And we're trying to figure out 2 to what power equals 8. Okay, well, we know 2 times 2 is 4. 4 times 2 is 8. So 2 to the 3rd equals 8. So log base 2 of 8 equals 3. Okay, if you want to try the next couple, if you think you got the hang of it, go ahead. So the next one, 7 to what power equals 7. So again, just really trying to reiterate that relationship between logs and exponents. So how many times do we multiply 7 by itself to get 7? Just one time. And so anytime that that base equals the argument, okay, this base equals the argument, that log is going to equal 1. Okay, and then the last one here, we're trying to figure out 5 to what power equals 125. So we know 5 times 5 is 25. If we multiply 25 times 5, we get 125. And so 5 to the 3rd equals 125, and so that log equals 3. Okay, so let's kind of summarize what we just found. The relationship between logarithms and exponents. Okay, so the base of the log is the same as the base of the exponent. And then we have this term called the argument. This is the value of the exponent. So if b to the a equals n, okay, then that value of n, that power, is going to go right here. Okay, also known as the argument. Okay, and then lastly, logs equal exponents. And so whatever the log is equal to, that is the exponent of your exponential equation. Now, a couple notes. If no base is written, it is assumed that the base is 10. So the example says log of 100 equals 2. So notice log of 100, you don't see a base there. So how do we know that that equals 2? Okay, well, if you have no base, then we assume the base is 10. Okay, so the reason log of 100 equals 2 is because 10 squared equals 100. So remember, when we try to evaluate that log, we're trying to figure out 10 to what power is 100, and so that would equal 2. Okay, and then another example, we're not going to talk very much about natural logs, but I do want you to at least recognize the notation. So another type of logarithm is called a natural log, and it has a base of e, and e is that number 2.718 that we talked about a little bit at the beginning of the unit. So an example would be ln of e equals 1, okay, and the reason ln of e equals 1 is because if you see ln, okay, there's not going to be an additional base written. You assume the base is e, so e to what power equals e? Well, that would have to be a 1. Okay, and again, I'm not going to ask you to evaluate natural logs. I just want you to recognize that ln represents a log with a base of e. All right, so if you want to try some of these, if you feel pretty confident, go ahead and try the next 3 problems. Otherwise, I will go ahead and explain these one more time. So log base 3 of 27. So we're trying to find an exponent. Okay, so 3 to what power equals 27? Okay, the next one, I'm going to kind of leave that blank and give you guys some time to think. So I just want to kind of lead you to the answer this time. Okay, so in the next one, log of 10,000. So we don't see a base, and so we assume the base is 10. And so can you figure out 10 to what power equals 10,000? Okay, and then the last one, we're trying to figure out 2 to what power equals 32. Okay, so if you can pause the video and complete those problems, just kind of leading you to the answer there. All right, so the first one, you should have gotten 3. The second one, just count the zeros, or you can use your calculator if you need to, but 10 to the 4th is 10,000. And then the last one, 2 to the 5th is 32. Okay? Now, in the last set of problems we're going to look at, we're going to have to use some properties of exponents. So the first property, any base to the 0 power equals 1. Okay, the second property is the negative exponent property. Remember, if you have a base to the negative power, that's the same as 1 over the base to the positive power. So an example, something like 2 to the negative 3rd, we know is the same as 1 over 2 to the positive 3rd. And so that would equal 1/8. And then the last property that you are going to have to use is that rational exponent property. So remember, if you have a base to like the 1/2, that's the same as the square root, or a base to the 1/3 is the same as the cubed root. Okay, so 25 to the 1/2, remember, equals the square root of 25, which is 5. Similarly, if you had something like 8 to the 1/3, that would be the cubed root of 8, which is 2. Okay? All right, so let's look at some kind of level 2 problems here. So we're still evaluating logs. We're still going to do the same setup here. Okay, so for this next one, 16 to what power equals 1? Okay, so 16 to the 0 power equals 1. Anytime that your argument here is 1, the answer is always going to be 0, because any base to the 0 power equals 1. All right, so the next one, we're trying to figure out 2 to what power equals 1/2. Okay, well, we know 2 to the first power equals 2. And so how did that 2 get on the bottom? It must have been a negative exponent. Okay, so log base 2 of 1/2 is -1. So notice if your base is a whole number and then you end up with a fraction with a 1 on top, then your exponent is probably going to be negative. All right, next one. 2 to what power equals 1/8. So that 1 there kind of is a hint that your exponent's going to be negative. So we know 2 to the third is 8. And so this must be 2 to the -3rd, which is 1/8. And so that log equals -3. All right, now the next example, we've got 36 to what power equals 6. Okay, now the key here, it's not 6 to what power is 36. Notice we're getting smaller. We're going from 36 down to 6. So what did we do to that 36 to get it down to 6? Oh, there we go. My screen seemed to have been frozen. All right, so if we do one single step to 36, what can we do to 36 to get it down to 6? So what I want you to notice here is that we can take the square root of 36 to get 6. Okay, but we can't just put a square root sign. We got to use an exponent. And so 36 to the 1/2 power equals 6. And so this answer is 1/2. So you got to be careful. Make sure you start with the base and go to the argument. Okay, so the next one is similar. We're going to start with 27, and we're trying to figure out 27 to what power equals 3. Okay, and so we can take the cubed root of 27 to get 3. And so we're going to write that as 27 to the 1/3. Okay, so notice big to small, that exponent is a fraction. Okay, and then the last one, we have log of 1. So this is just a reminder about that common base, or that common log. The base here is 10. 10 to what power equals 1. Anytime that argument is 1, it's going to be a 0 exponent. Okay, so if you understand that, you think you got the hang of it, go ahead and stop the video and try the last set of problems. Okay, I'm going to set you up kind of like I did the last time, and then if you can fill in your numbers, that would be great. Otherwise, if you want to hang with me the whole time, that's okay too. All right, so this one, we're trying to figure out 7 to what power equals 1/49. Okay, the next one, we don't see a base, so the base is 10, and we want to know 10 to what power equals 1,000. The next one, 8 to what power equals 1. And the last one, 25 to what power equals 5. Okay, so see if you can, if you had trouble setting up, see if you can finish the problem from there, and then check your answer. So this one's going to be -2. This one, count your zeros. We need 3 zeros, 10 to the 3rd. The next one, 8 to the 0 is 1. And then lastly, we're going from 25 to 5, which is smaller. So we need to do the square root of 25, which is 25 to the 1/2 power. Okay, so I hope that made sense. I'm going to give you a short assignment to complete and submit, and I will talk